In this chapter, we will understand the following concepts: factors and multiples, prime and composite numbers, common factors, common multiples, prime factorization, highest common factor, and lowest common multiple. Let's begin by understanding what are factors and multiples with the help of a scenario. If we wish to arrange 8 rows plants with different variations of rows and columns, we would actually be working on the factors of number 8. Let us have a look at all possible ways in which you can organize the 8 rows plants. You can place all the 8 plants in a single horizontal row. You can also place them in 2 horizontal rows of 4 plants each. 4 horizontal rows of 2 plants each, 8 rows with 1 plant in each row. So, there are 4 possible arrangements. Numerically speaking, number 8 can be represented as 1 into 8, 2 into 4, 4 into 2, and 8 into 1. Numbers 1, 2, 4, and 8 divide 8 exactly without leaving a remainder. Therefore, they are factors of 8. And 8 is the multiple of 1, 2, 4, and 8. Factors of a number are divisors that divide the number exactly. Multiples of a number are products of the number with any other number. So, for a number like 6, that can be represented as 2 into 3. 2 and 3 are factors of 6, and 6 is the multiple of 2 and 3. Now let's have a look at the properties of factors and multiples. 1 is a factor of every number. As we can see that 1 multiplied by a number is the number itself. 1 into 2 is equal to 2, 1 into 3 is equal to 3, 1 into 4 is equal to 4, so on and so forth. Every number divides itself exactly. Number is a factor of itself. As we can see, 2 divided by 2 is 1, 3 divided by 3 is 1, 4 divided by 4 is 1, so on and so forth. The factors of a number lie between 1 and the number itself. To understand this, let's have a look at the factors of 36. So we see that 1, 2, 3, 4, 6, 9, 12, 18 and 36 are the factors of 36. Another thing to be noted here is that factors of a number are fixed and finite and can never be greater than the number itself. On the other hand, the multiples of a number can be infinite. If we take the example of number 2, you will see that whichever number you multiply 2 with is a multiple of 2. 2 into 4 is 8, 2 into 26 is 52, 2 into 40 is 80, so on and so forth. So there is no limit for the multiples of a number. Multiples can be infinite. So factors are finite and multiples are infinite. To summarize, 1 is the factor of every number. Number itself is also a factor. The number of factors are finite. Number of multiples are infinite. Factors are equal to or less than the number. Multiples are equal to or greater than the number. Let's move on to prime numbers and composite numbers. Prime numbers are the numbers that have exactly 2 factors, 1 and the number itself. Let's look at the factors of 7, 11, 13 and 17. 7 gives us 7 into 1, which is 7. 11 gives us 11 into 1, which is 11. 13 gives us 13 into 1, which is 13. 17 gives us 17 into 1, which is 17. So these numbers have only 2 factors, 1 and the number itself. All such numbers are called prime numbers. Now let's talk about composite numbers. Composite numbers are the numbers that have more than two factors. Let's look at a few numbers like 6, 9 and 15. Factors of 6 are 1, 2, 3 and 6. Factors of 9 are 1, 3 and 9. Factors of 15 are 1, 3, 5 and 15. As you can see that 6, 9 and 15 have more than two factors. So these are composite numbers. All the numbers are either prime or composite. 1 being an exception. 1 is neither prime nor composite. It has only one factor, that is the number itself. The test of divisibility. What do we mean by divisibility? A number is said to be divisible by another number if the division leaves no remainder. Let's take an example. We take the number 8 and see if it is divisible by 2. Dividing 8 by 2 should not be difficult. As you can see that 8 gets divided by 2 completely and leaves no remainder. So we can say that 8 is divisible by 2. The number being small, it was very easy to find out the divisibility of 8 by 2. But how do we check the divisibility if we are dealing with big numbers? For this purpose, there are different tests designed to test the divisibility of numbers by 2, 3, 4, 5, 6, 8, 9, 10 and 11. Let's check out the test for finding out divisibility of a number by 2. Let's take a big number like 48768. In order to find out its divisibility by 2, we either carry out the division and see if we get the remainder as 0 or avoid a long drawn division and run the divisibility test. For that, we need to check the last digit of the number. If this last number is even, then it will be divisible by 2. In this case, the last number is 8, which is an even number, that is divisible by 2. So, the complete number 48768 is divisible by 2. If the number was 48767, it would not be divisible by 2, as in this case, the last digit is 7, which is not an even number. Now let's check out the test for finding divisibility of a number by 3. In the divisibility test for 3, we need to add all the digits in a number and see if the resultant number is divisible by 3 or not. Let's take a number 4362. Now adding all the digits of the number 4 plus 3 plus 6 plus 2, we get 15. And 15 is divisible by 3. So the number 4362 is divisible by 3. To check the divisibility of a number by 4, we need to check the last two digits of the number. That is tens place and ones place. In order to understand it better, let's take a number 8732. We can see that the last two digits here are 3 and 2, and the number that we get from these digits is 32. Now we have to see if this number comes in the table of 4 or not. If we recall the table of 4, 4 8s are 32. So 32 is very much there in the table of 4, which implies that 8732 is divisible by 4. However the bigger number it might be, all we have to do is check the last two digits and run it through the table of 4. If it appears in the table, the number will be divisible. If it does not appear in the table of 4, the number will not be divisible. To check the divisibility of a number by 5, we just have to look at the last digit of the number. If the last digit of the number is 5 or 0, the number will be divisible by 5. For example, the number 87425 will be divisible by 5. The number 87420 would also be divisible by 5. But if the numbers are 87426 or 87428, they will not be divisible by 5. To be able to check the divisibility by 6, You need to know the divisibility test for 2 and 3. Any number that is divisible by 2 and 3 will be divisible by 6 also. To understand this, let's take a number 63984. If we check the number's divisibility by 2, we can see the last digit is 4, which is divisible by 2. For checking the divisibility by 3, we will need to add all the digits of the number. So, adding 6, 3, 9, 8 and 4, we get 30. And 30 is divisible by 3 as it appears in the table of 3. So we see that number 63984 is divisible by 2 and 3 both. So it will be divisible by 6 also. Let's take one more example and change the number a bit. Let it be 74984. The last digit of the number is 4, which is even and hence divisible by 2. Let's check the divisibility by 3 now. Adding all the digits 7, 4, 9, 8 and 4, we get the sum as 32. Now 32 is not divisible by 3 as it does not appear in the table of 3. So we see that the number 74984 is divisible by 2 but not divisible by 3. If the number is not divisible by any one of the numbers out of 2 and 3, it will not be divisible by 6. For the number to be divisible by 6, it has to be divisible by both 2 and 3. In case of divisibility by 4, we check the last two digits and see if the number represented by last two digits is divisible by 4 or not. In case of 8, we need to check the last three digits of the number. So, the test of divisibility by 8 is applicable only on the numbers with 4 or more digits. Let's take an example to understand this. Let the number be 736512. As we see that the last three digits in this number are 512. Now we have to see if 512 is divisible by 8 or not. This time we will have to actually divide the number formed by the last three digits, which is 512. As we divide 512 by 8, we are not left with a remainder. So, if the number formed by the last three digits 512 is divisible by 8, then the entire number 736512 will be divisible by 8. Now let's move on to check the divisibility by 9. As in the case of divisibility by 3, we will add all the digits of a number and see if the resultant number is divisible by 9 or not. Let's take the number 23985 to understand this. Let's add 2, 3, 9, 8 and 5. The sum of these digits is 27. 27 appears in the table of 9 and is surely divisible by 9. So the number 23985 is divisible by 9. The test of divisibility by 10 is probably the easiest. All we have to do is check the last digit of the number. If the last digit is 0, then the entire number will be divisible by 10. Numbers like 97630 and 45820 would be divisible by 10, whereas numbers like 45762 and 34578 will not be divisible by 10. Let's understand the technique to find out the divisibility by 11 with the help of an example. Let's take a number 1023. This has to be done in 3 steps. Add the digits at odd places, then add the digits at even places. Subtract the two resultant numbers and see the result. If the result is 0 or a number divisible by or a multiple of 11, then the number will be divisible by 11. So let's do it with the number 1023. In step 1, let's add the digits at alternate odd places, that is the first number and the third number in case of 1023. Here the first number is 1 and the third number is 2. The sum that we get is 3. Now let's add the alternate digits at even places, which are 0 and 3. The sum that we get is 3. Now we have to subtract the sum that we got from step 2 from the sum that we got from step 1. That is 3 minus 3, which is 0. As we have got the 0 here, it means the number 1023 is divisible by 11. Let's now move on to the next topic, common factor. Let us list the factors of two numbers to understand the concept of common factor. Let the numbers be 8 and 12. The factors of 8 would be 1 into 8, 2 into 4, 4 into 2, and 8 into 1. And the factors of 12 would be 1 into 12, 2 into 6, 3 into 4, 4 into 3, 6 into 2, and 12 into 1. Here we see that 1, 2, 4, and 8 are the factors of 8. 1, 2, 3, 4, 6, and 12 are the factors of 12. Do we see any common factors here? Yes. 1, 2, and 4 are the common factors of 8 and 12. Let's take one more example. This time, let us have a look at the factors of 7 and 8. The factors of 7 are 1 into 7 and 7 into 1. And the factors of 8 are 1 into 8, 2 into 4, 4 into 2, and 8 into 1. In this case, we see that 1 is the only common factor between 7 and 12. If 1 is the only common factor between any two numbers, the numbers are known as co-prime numbers. Now let's discuss common multiples. If we have two numbers, what could be the common multiples between them? Let's take the numbers 4 and 8 to understand this. Let's list a few multiples of 4, which would be 4, 8, 12, 16, 20, 24, 28, 32, and so on. Similarly, let us list the multiples of 8, which would be 8, 16, 24, 32, 40, and so on. So do we observe any common multiples here? Yes, of course. We have 8, 16, 24, and 32, which appear in the multiples list of both 4 and 8. So 8, 16, 24, and 32 are the common multiples of 4 and 8. If we decide to extend the list of multiples in both the cases, we will come across many more common multiples of 4 and 8 in this case. Let's move on to the topic of prime factorization. A number is prime factorized when we break the number into its prime factors. Let us see how it is done. Expressing 48 as 12 into 4 is factorization, but the factors 12 and 4 are composite. We can further break 12 and 4 to get the prime factors. 12 can be further factorized as 3 into 4, and 4 can be further factorized as 2 into 2. So 48 can be factorized as 3 into 2 into 2 into 2 into 2. So 3, 2, 2, 2, 2 are the prime factors of 48. Large numbers are prime factorized through repeated division by prime numbers till the quotient is itself a prime number. Let us prime factorize 430 by division method. First we divide 430 by prime factor 2. Next we divide the quotient 215 by the prime factor 5 to get the quotient 43. Since 43 is not divisible by any other number, we divide it by 43 to get the quotient 1. So we get the prime factors for 430 as 2 into 5 into 43. We have learned common factor. Now it's time to get to know about highest common factor for a set of numbers. Let's take three numbers and identify the highest common factor. Let the numbers be 12, 15, and 18. 12 is equal to 3 into 4. 15 is equal to 3 into 5. and 18 is equal to 3 into 6. Here you can see the common factor is 3. So 3 is the HCF of 12, 15 and 18. There can be another scenario while finding the HCF. Let's take another example and see what can that be. Let's find the HCF of 36, 45 and 90 using prime factorization. 36 is equal to 3 into 3 into 2 into 2. 45 is equal to 3 into 3 into 5. And 90 is equal to 3 into 3 into 2 into 5. A close observation of the prime factors of 36, 45 and 90 tells us that 3 is the common factor here, but it appears twice. Therefore, the highest common factor of 36, 45 and 90 would be 3 into 3, which is 9. Now let's move on to least common multiple. LCM is the smallest of all common multiples of two or more numbers. Let's understand this with the help of an example. Let's list the multiples of 5, 10 and 20. Multiples of 5 would be 5, 10, 15, 20 and so on. Multiples of 10 would be 10, 20, 30, 40 and so on. Multiples of 20 would be 20, 40, 60, 80 and so on. You would observe that the first common multiple of 5, 10 and 20 is 20. Therefore, least common multiple of 5, 10 and 20 is 20. We can also find the LCM by prime factorization method. Let us use this method to calculate the LCM of 16, 24 and 32. This method involves dividing the set of numbers by prime factors till the quotient is 1. Let us start with the smallest prime factor that divides at least one of the three numbers. 2 is the smallest prime number that divides 16, 24 and 32. We can continue to divide the quotients till it is not possible to divide any quotient by 2. The next smallest prime factor that divides one of the remaining quotient 1, 3 and 1 is 3. Now multiply all the divisors. The LCM of 16, 24 and 32 is equal to 2 into 2 into 2 into 2 into 2 into 3, which is 96.